Hello dear students, today we are going to talk about enzymes, the nature's catalyst. So before actually moving on to the topic, let us see the history of the enzymes and what enzymes are. They are the biomolecules, they are the indispensable biological catalyst which orchestrate the myriad metabolic reactions essential for the different life processes. They have a profound impact on the biochemistry and very essential in centuries in fermentation technique, in molecular and biotechnological fields. It is very commonly used biomolecule. Okay, so let us understand what are enzymes. So here we can see the fascinating history and discovery of enzymes. Here you can see it was the first, you know that it is unknowingly the enzymes are used for since years. They are used for bread, beer and cheese making, as well as meat tenderizing. Pepin is used, you know that. Kunne, Sumner and Buchner were three scientists which were involved in the discovery of a journey of enzyme discovery. Okay, so the first one is 1833. What happened first is the Payen isolated the enzyme diastase, which was able to convert a polysaccharide starch into a sugar monosaccharide. And that was the beginning of the discovery of enzyme. Okay, in 1877, actually Kunne had discovered the term enzyme, which are involved in the life processes. Then came Buchner, and he proved that the enzymes work outside the living organism, living cells, or outside the body of the living organism also. So self-free fermentation he has invented, and the enzymes are able to function outside the body of the organism. It was discovered by Buchner. Okay, then J.B. Sumner came and he worked on urease, which was working on the urea, okay, protein degrading enzyme, okay. So pure protein, showing the enzymes, and he proved that enzymes are proteinaceous in nature, and he got a Nobel Prize for this in 1926. So Sumner has done that job of discovering the nature of the chemical nature of the enzyme, that is, they are proteinaceous in nature. Now today, the enzyme revolutionized the food, medicine, and ase is the suffix which is commonly used. So these are the common, you can say, features of the enzymes which you can know. So what are enzymes? You can say that enzymes are the biological catalyst which increases the rate of reaction by lowering the activation energy. Now let us understand this. Now let us understand this definition. So enzymes typically involve the enzymes are substances which are produced by the living organism, act as a catalyst to bring about the specific biochemical reaction. They bring out a change in the reaction and help in the formation of a product. Now if you talk about enzyme, it will require a substrate to react on. So substrate is the molecule which on which the enzyme will act on, and which the enzyme will act on, and it will catalyze the chemical reaction. So what are the characters, nomenclature and everything? Enzymes naming conventions typically involve the addition of suffix ase to the name of the substrate on which they act. Okay, so you will see ase, diastase, urease, acid phosphatase. Okay, so ase is the suffix which provides a clear and concise descriptor about their function. Okay, so IUB, International Union of Biochemistry, for enzyme classification, they have given the nomenclature. So enzyme generally has a four-part nomenclature system. That is, it's a class, subclass, subclass, and serial number. As we classify the organism like kingdom, domain, kingdom, phylum, class, order, subclass, etc., etc., till genus and species. Similarly, the enzymes are also classified in the same manner. Okay, for instance, here you consider alcohol dehydrogenase. Enzyme classification 1.1.1.1. Here it belongs to oxidoreductase class. So 1 denotes that it belongs to oxidoreductase. And further their subclass, which kind of reaction they conduct, etc. etc. Hexokinase 2.7.1. So this is how enzyme classification 2.7.1.1 falls under the transferase category, illustrating its systematic organization and position in the enzyme system. Now, if you talk about how do they work, so here this is an enzyme and this is a substrate. So it is like lock and key. So they have some cavities which we call it as active site, and into this cavity or the active site the substrate molecule will fit up in. Okay. Now the substrate molecule could be anything. It could be a protein, or it could be generally proteinaceous in nature, but it could be any other material as well. So the its substrate will fit into the active site of enzyme. The enzyme changes its shape slightly. According to some theory, it is lock and key model. Nobody will change the shape, neither the enzyme nor the substrate. But some theories say that the enzyme will changes the shape a bit as substrate can fit into it. Okay, then it will form an enzyme substrate complex. It will then further form the product enzyme product complex, and the product will be dissociated from the enzyme. The product will leave the active site of the enzyme. This is how the enzyme are going to help in the formation of product without being consumed into the reaction. Okay, this is a characteristic feature. So what are the fundamental properties of the enzyme? Are they affected by any factors? So enzyme exhibit a remarkable characteristic that underpin their biological functionality and efficiency. Here are some the properties are crucial for maintaining the intricate balance of the cellular processes. For example, high specificity. So one enzyme will have particular substrate, one substrate only. Enzymes are executively selective, typically acting on only one or the few substrate. They cannot act on different substrate. Okay, there is a specific substrate for specific enzyme. Specificity is their property. uh, Environmental sensitivity. The enzyme's activity is higher at their optimum pH. They can function at a maximum at their optimum pH, optimum temperature. If that gets fluctuated a bit, they will not be able to function. The enzyme activity is highly sensitive to environmental factors like temperature, pH, substrate, etc. etc. And catalytic efficiency. They lower the activation energy for the reactions. For example, if you want to go from place A to place B by walking, okay, if you want to go by walking by road, then if it is taking 10 minutes to go reach at a place from A to B, but if you use a vehicle to reach from place A to place B, it is taking a lesser time, right? And it is going to save your energy. See, for example, it will take 5 minutes. Similarly, the enzymes will also work in the same manner. If a reaction is occurring, reaction is taking XYZ amount of activation energy to complete. So it will reduce that energy, activation energy, and carry that task earlier in lesser time and in lesser energy. Accelerate, it will accelerate or increase the rate of reaction millions or billion times without being consumed in the process, and they can be used further. They emerge unchanged and readily catalyze the further reactions. So these are the properties of enzymes. High turnover rate. Many enzymes possess incredibly high turnover rate, meaning that they can convert large number of substrate molecule into product per unit time. For example, without enzyme, if there are 10 molecules getting formed in 1 minute, so if you use an enzyme in 1 minute, you can go for multiple molecules like 10,000 or 100 or so many in one minute. Okay, this is just an example. So it will increase the production. For example, a catalyst can process 6 million substrate molecules per minute. This is the enzyme. Okay, So it will increase the turnover rate and increase the product formation. Here you let us understand how does the enzyme works. It lowers the activation energy. मतलब क्या है? What it does exactly. Here is a reaction coordinate. Here is a potential energy which is used. For example, if you talk about a non-catalyzed reaction where there is no enzyme and here the enzyme is used. This is an enzyme catalyzed reaction. Okay. So here are the reactants. Okay, here are the reactants and here is a free energy which is used, transition energy. So this is the activation energy which is used. For example, EA is the uncatalyzed energy, activation energy used for the uncatalyzed reaction. Okay, EA. Okay, this reaction is maximum. If we compare, this reaction is more, activation energy is more if we look at than the if you look at the catalyzed reaction, it is minimum than the uncatalyzed reaction. So for uncatalyzed reaction, maximum activation energy is required to reach the transition state and form the product. Whereas if you talk about catalyzed reaction where the enzymes are acting as a catalyst and increasing the rate of reaction, the activation energy which is required to reach to the transition state is minimum, and the same transition state can be achieved by using a minimum activation energy and the products can be formed. Okay, so this is how by lowering the activation energy the enzymes are capable of catalyzing the reactions. This is how they will be catalyzing the reactions. Okay, so this is how it is happening. So I have here are the two theories, but these two theories of enzymes, how they work, that we will see in the next part. By the time, stay tuned with Life Science with Veena, Life Science with Veena for more such videos. Thanks a lot. Bye bye.